The human interface for excavators have not changed significantly over many years. Traditionally, two spring-centered joysticks, each with 2 degrees of freedom, have been used by operators. Each joystick axis controls a single hydraulic actuator. These types of controls require a long learning process to be able to use effectively. Since no single joystick mapping standard has emerged in the industry, operators may have to adapt to different mappings between joystick axis and the arm joint axis when they change machines. In addition, the standard joysticks do not provide any force or tactical feedback. They require a high degree of coordinated control and precision to perform such complex tasks as leveling and blind digging. Machine operators have to learn the controls of machine with different kinematic parameters, making use of vision to estimate the elements of each movement. Operators must rely on secondary parameters such as engine noise to estimate control of bucket forces. These difficulties are even more pronounced when remote operation of machines is required, such as in handling and removal of hazardous waste. Since electro-hydraulic systems with electronic joysticks have become available for serial applications, alternative operational concepts become feasible. An alternative is to control the machine using an operating device whose segments resemble the manipulator geometry. This concept is called coordinated control. The integration of the sense of touch in the human-machine interface promises an easier, faster, and more intuitive operation than the typically encountered visual information. Haptic interfaces have advantages compared to human-machine interfaces that do not integrate the sense of touch, especially if the operator has to work delicately and accurately, or if various materials with different elasticity are handled.
The primary advantage of utilizing teleoperation is the distance of human life from potentially hazardous situations. From January 2, 2012 through September 30, 2013, there were over 400 reported deaths and over 1,000 injuries from the use of excavators. By removing the operator to a safe location outside of the excavator, it is possible to avert accidental bodily harm or death. While it may not be possible to prevent excavators from being crushed, overturned, or entrenched, this one simple device assures that when such mishap occurs, a human being will not be trapped inside of an excavator. Another advantage of teleoperation is that the operator can see the entire situation. They can see where the excavator is, where the workers are, and there will be no blind spots the excavator can avoid striking a fellow worker. Telecommunication provides the manipulation of an excavator in such a way as to allow an operator to perform a task at a distance. This is usually done because of a hostile environment where human access is difficult, but human intelligence is necessary. Teleoperated excavators use different sensors to let the user operate them safely. The operator can choose the best location for the work, either close to the attachment when precision is required, or at a distance when near unstable structures. The most common method for teleoperation control is through direct control. Traditionally, hand controllers are used to control the system while monitoring video feedback from cameras mounted on the teleoperated system. In direct control, the remote operator is controlling the system in the same way as an onboard operator would. Direct control techniques are appropriate when real-time human decision-making and control is required, and when the environment can support high-bandwidth, low-delay communications. Control of the excavator should be as similar as possible to conventional operation. Removing operators from the vicinity of work sites introduces many technical challenges: low situational awareness in unknown environments, complexity of operated machines, and the need for high-bandwidth real-time communication. Teleoperation is often implemented in difficult-to-reach environments to improve task efficiency and to reduce human risk. Remote operation of excavators has applications in such areas as forestry, mining, and underwater excavations. Finally, development of teleoperated platforms paves the way for more intelligent systems that do not need input from the operator constantly. For example, typically loading a truck requires several passes, each of which takes 15 to 20 seconds. Systems have been developed for loading trucks fully autonomously with soft materials such as soil. Reducing the time of each loading pass by even a second translates into an enormous gain across the entire job. The operator's performance peaks early in the work shift and degrades as the shift wears on. Scheduled idle times, such as lunch and other breaks, also diminish average production across a shift. All of these factors are areas where automation can improve productivity.